Hello, future scientists. I am Atom. Today, we are immersing ourselves in the dynamic world of velocity time graphs. Velocity time graphs are a powerful tool in physics that provide a visual representation of an object's motion over time. How to read velocity time graphs? The horizontal axis usually represents time in seconds, and the vertical axis represents velocity in meters per second. Let us look at this scenario. Isaac is running. Here are the velocity time graphs that show how Isaac is running. Question 1. Explain how Isaac is running in case 1. A horizontal line on the VT graph signifies constant or unchanging velocity. If the horizontal line is above the time axis, it represents constant positive velocity. Positive velocity indicates motion in the direction that is defined as positive, usually rightward or upward motion as in the Cartesian coordinate system. For example, if Isaac runs at a positive constant velocity, he moves eastward when east is designated as the positive direction. Question 2. Explain how Isaac is running in case 2. If the horizontal line is below the time axis, it represents constant negative velocity. A negative velocity indicates motion in the opposite direction to the established positive direction. For example, if Isaac runs at a negative velocity, he moves westward when the positive direction is set as east. Question 3. Explain how Isaac is running in case 3. A line that slopes away from the x-axis in the positive quadrant means Isaac's velocity is increasing in the positive direction. In this case, both velocity and acceleration are in the same positive direction. This means that Isaac is speeding up. Question 4. Explain how Isaac is running in case 4. A line that slopes towards the x-axis in the positive quadrant means Isaac's velocity is decreasing in the positive direction. In this case, velocity and acceleration are in opposite directions, which means Isaac is slowing down. Question 5. Explain how Isaac is running in case 5. A line that slopes away from the x-axis in the negative quadrant means Isaac's velocity is increasing in the negative or opposite direction. Both the velocity and acceleration are in the same negative direction. Therefore, in this case, Isaac is speeding up in the reverse direction. Question 6. Explain how Isaac is running in case 6. A line that slopes towards the x-axis in the negative quadrant means Isaac's velocity is decreasing in the negative or opposite direction. His velocity and acceleration are in opposite directions. In this case, Isaac is slowing down in the reverse direction. Therefore, it is important to remember that the velocity goes up if both velocity and acceleration are in the same direction, and velocity goes down if velocity and acceleration are in opposite directions. How to calculate acceleration from a velocity time graph? Acceleration is the rate of change of velocity. Formula for acceleration is A equals change of velocity divided by time. Or we can say A equals delta V over delta T, where A is the acceleration in meter per second, Delta V is the change in velocity, which equals Vf minus Vi, or velocity final minus velocity initial in meter per second. And delta T is the time interval in seconds. Slope of a velocity time graph equals rise divided by run, which equals Vf minus Vi divided by Tf minus Ti, which equals delta V over delta T. The Tf and Ti mean the time final and the time initial. Thus, the slope of a Vt graph, which equals delta V over delta T, gives us the acceleration of the object during the specific time interval. Let us look at this scenario. Ion is biking. The graph shows ion's motion. Question 7. What is ion's acceleration from 0 to 4 seconds? A equals delta V over delta T, or in this case we can just do rise over run, which equals 3 meter per second divided by 4 seconds. That equals 0.75 meter per second per second. Question 8. What is ion's acceleration from 7 seconds to 10 seconds? Doing the rise over run calculation, we see that the delta V over delta T here is negative 6 meter per second divided by 3 seconds. So it is equal to negative 2 meter per second. Question 9. What is ion's acceleration from 4 seconds to 6 seconds? It is a horizontal line, so the slope is 0. So acceleration equals 0 meter per second. How to read a velocity time graph if a line crosses the x-axis or the time axis? A line crossing the time axis indicates a change in direction. The positive and negative areas on either side of the axis represent motion in opposite directions. Question 10. The graph shows the motion of Isaac skiing. Explain Isaac's motion at 3 seconds. At 3 seconds, Isaac changes his direction and starts to speed up in the opposite direction. How to calculate displacement from a velocity time graph? The area under the velocity time graph represents the displacement of the object. This is because velocity equals delta D over delta T. So delta D equals the velocity times the delta T. Question 11. Ion is biking. Calculate her displacement based on the graph shown below. For uniform motion that is moving at a constant velocity, the shape of the area under the graph, as you see here, is a simple rectangle, which is just base times height. So ion's displacement equals plus 4 meter per second times 4 seconds, which equals plus 16 meters. Question 12. Calculate ion's displacement based on this graph. As you see, ion is speeding up in the positive direction. So ion's displacement equals area of the triangle, which equals half times 15 seconds times 6 meter per second, which equals plus 45 meters. Question 13. EXO is roller skating. Calculate her displacement from time 0 seconds to 3 seconds. Split the shape of the graph below into 2 triangles and a rectangle, that is from time 0 seconds to 3 seconds. Area of shape 1 equals half times 1 second times 3 meters per second. That equals plus 1.5 meters. Area of shape 2 equals 0.5 seconds times 3 meters per second, which equals plus 1.5 meters. And area of shape 3 equals half times 1.5 seconds times 3 meters per second, which equals plus 2.25 meters. So Exo's displacement will be the sum of these three areas, which equals plus 5.25 meters. Question 14. Calculate Exo's displacement from time 3 seconds to 6 seconds. The shape is a triangle and it is in the negative quadrant. Area of this shape 4 equals half times 3 seconds times negative 3 meters per second, which equals negative 4.5 meters. So Exo's displacement in this case equals negative 4.5 meters. Question 15. What is Exo's total displacement from time 0 seconds to 6 seconds? So all we have to do now is add up her displacements from 0 to 3 seconds and 3 to 6 seconds. So her total displacement will be equal to plus 5.25 meters plus negative 4.5 meters, and that equals plus 0.75 meters. There you have it, the physics of velocity-time graphs. Understanding velocity-time graphs helps us to calculate acceleration, direction changes, and displacement of moving objects. Happy learning! Thank you.